Hello everyone. Let us discuss some of the important models in optics, that is a reflection of light in curved surfaces. The first question, the image formed by a spherical mirror is real, inverted and its magnification is -2. If the image distance is 30 centimeters from the mirror, where is the object placed? Find the focal length. The given mirror name is not given, so the name of the mirror is concave because only concave mirror forms real images. And magnification value m equals to -2 and image distance equals to 30 centimeters. We have to find object distance and focal length of the mirror. Before solving the problem, we need to write the sign conventions for the given measurements. So image distance is 30 centimeters. That to real image means the image is formed on the screen. Means it is formed before the mirror. So the distances which are taken before the mirror are considered as a negative. So v equals to -30 centimeters. The magnification formula m equals to minus v by u. M equals to -2 and v -30 by u. Minus minus cancel, 2 ones are 2 15s are, u equals to -15 centimeters. Next we have to find the focal length of the mirror using mirror formula. 1 by f equals to 1 by v plus 1 by u, and 1 by f equals to, what is the v value? -30 and u equals to -15. So -1 by 30 minus 1 by 15, 1 by f equals to, LCM is 30, 30 cancel, -1, 15 ones are 15 twos are -2, 1 by f equals to -3 by 30, 3 ones are 3 tens are, making reciprocal on both sides, f equals to -10 centimeters. So the focal length of the mirror is -10 centimeters. Focal length negative indicates the given mirror is concave mirror. Next question. A concave mirror produces 3 times magnified real image of an object placed at 5 centimeters in front of it. At what distance from the front of the mirror is the image located? Means you have to find the image distance. So the given mirror is concave mirror. Magnification m equals to -3 because the image formed is real. When the image formed is real, the magnification value will be minus. And also given object distance u equals to 5 centimeters, apply the sign convention rules, -5 centimeter because object distance always taken minus. And also the question is, we have to find the image distance. Simply the magnification formula m equals to -v by u. Substitute m equals to -3, v we don't know, -v, u equals to -15 -5 centimeter. Minus minus cancel, on cross multiplication v equals to -15 centimeters. Next question. A mirror forms 3 by 4th of object size on the screen. If the object distance from the pole of the mirror is 16 centimeter, then find the focal length of the mirror. Let us read the question carefully. A mirror forms 3 by 4th of object size on the screen. If the object distance from the pole of the mirror is 16 centimeter, then find the focal length of the mirror. We don't know what is the mirror name here. First of all, let us write the given. Size of the image equals to 3 by 4th of object size. So let us write it is hi by h naught equals to 3 by 4. Now hi by h naught can be written as a m magnification 3 by 4. But the image formed is real, so I can take in the magnification value minus 3 by 4. As image formed is real, the given mirror is concave mirror. Concave mirror. And next it is given object distance u equals to minus 16 centimeters after applying sign convention rule. So we need to find the focal length of the mirror. Before finding the focal length of the mirror, let us find the what is the v equals to. Magnification of the mirror m equals to minus v by u. M value minus 3 by 4, which is equals to minus v, u equals to minus 16. Minus minus cancel, 4 ones are 4 fours are. Now v equals to 3 fours are 12 centimeters. So image distance equals to 12 centimeters. So we need to find the focal length of the mirror using mirror formula. 1 by f equals to 1 by v minus plus 1 by u. Next v equals to minus 12 plus 1 by u minus 16. You have to find the LCM of 12 comma 16. Now tell me what is LCM of 12 comma 16. 4 threes are 4 fours are. How much you got? Huh? What doing? 48. 48. 12 fours are 48. 16 threes are. So f equals to 1 by f equals to minus 7 by 48. We are making reciprocal on the both side. F equals to minus 40 by 7 centimeters. This is the focal length of the given mirror. As the focal length is negative, you can confirm that the given mirror is concave mirror. The next question. A, B, C, D, two spherical mirrors. You can observe in the diagram A, B, C, D are two spherical mirrors. From parts of a hollow spherical ball with its center at O. Center at O as shown in the diagram. If the arc length AB equals to 1 by 2 of arc length of CD, means AB is half of the CD. The arc length of AB is half of the CD. What is the ratio of their focal lengths? The question is, what is the ratio of their focal lengths? State which of the two mirrors will always form virtual image of an object placed in front of it and why. Now let me take first of all, let me decide which mirror is going to form virtual image. If you consider AB, the mirror, this mirror is convex mirror, convex mirror, and this mirror is concave mirror because reflecting surface is inside. Concave mirror. Now we know that only convex mirror forms virtual, erect, and diminished images. Diminished images. And concave mirror can also forms virtual image, virtual erect, and enlarged images. So, what is the question? Which of the two mirrors always form virtual image? Always forms virtual image by only convex mirror. The right answer is, you can give the name of the mirror A, B. So only convex mirror can always form virtual images. Means convex mirror never form real images. And also the question is, what is the ratio of their focal lengths? Now, what is the focal length? How do you define the focal length? Focal length equals to F equals to half of the radius of curvature. Half of the radius of curvature. So O is the center. Now this is the R1 and this is the R2. The both radii of curvatures of the mirrors are equal. R1 equals to R2, let's say, which is equals to R. Let's say that their focal length F1 is the convex mirror focal length, F2 is the concave mirror focal length. So F1 equals to how much? R by 2. F2 equals to how much? R by 2. So we can cancel them, both are equal. Therefore, F1 by F2 equals to 1 by 1. So F1 is to F2 equals to 1 is to 1. Next question. A concave mirror has focal length 20 centimeter. At what distance from the mirror should a 4 centimeter tall object be placed so that it forms an image at the distance of 30 centimeter from the mirror? Also calculate the size of the image. Now first the given is concave mirror, its focal length f equals to 20 centimeters. Since this concave mirror, apply the sign conventions. Concave means minus, convex means plus. Next, and also size of the object h naught is equals to 4 centimeters. Generally they are considered as a plus because they are placed above the principal axis. And also image is formed 30 centimeters from the mirror. Image distance equals to 30 centimeters. Let us read the question once more. A concave mirror has a focal length 20 centimeters. We have written focal length. At what distance from the mirror should a 4 centimeter tall object be placed of size of the object so that it forms an image at a distance of 30 centimeters from the mirror? From the mirror means the image is formed in front of the mirror. I told you already the distances which are means the object distance or image distance which is formed in front of the mirror are taken as the negative, so it is minus 30 centimeters. We have to find the u equals to how much. Now use the mirror formula. 1 by f equals to 1 by v plus 1 by u. F equals to minus 20, v equals to minus 30 plus 1 by u. Now tell me what is the LCM of 20 and 30? Hmm. Huh? 20 and 30 LCM. So 1 by u equals to minus 1 by 20 plus 1 by 30. If you don't know LCM, simply do have a cross multiplication. No. 10 ones are 10 twos are 10 threes are 10 twos are 10 threes are. You'll get a 60. Yes. Huh? 21s are 23s are 31s are 32s are. Now what is the 1 by u? 1 by u equals to minus 1 by 60. Then tell me what is object distance? minus 60 centimeters. In the next, he also asked to calculate the size of the image formed. So for that, let us calculate the magnification. M equals to minus V by U. Now V equals to how much? Minus 30. U equals to minus 60. 31 are 32 are. So M equals minus minus also cancel. So M equals to minus 1 by 2 means minus 0.5. So magnification minus means it indicates the image formed is real inverted, and less than 1 it is less than 0.5 means less than 1 is diminished image. And M equals to Hi by H naught. You asked to calculate what is the Hi. Hi is equals to M into H naught. M equals to how much? Minus 1 by 2. H naught is equals to 4 centimeters. 2 ones are 2 twos are. So Hi is equals to minus 2 centimeters. Next question. The image of a candle flame placed at a distance of 30 centimeter from a mirror is formed on screen placed in front of the mirror at a distance of 60 centimeter from its pole. What is nature of mirror? Find the focal length of the mirror. If the height of the flame is 2.4 centimeter, find the height of its image, and also state whether the image formed is erected or inverted. Let me write the given. Object distance equals to 30 centimeter. Object distance always taken minus, and the screen as placed in front of the mirror at a distance of 60 centimeters. The purpose of screen is to obtain a sharp image. Indirectly has given image distance is equals to 60 centimeters. So the distance is in front of the mirror is always taken minus. So it is minus 60 centimeter, and it this image is real image. Which image? By real image, because image is obtained on the screen. Okay. And in the question, what is the nature of the mirror? So tell me which type of mirror it is. Convex or concave mirror? Only concave mirror forms the real images. So concave mirror. Find the focal length means F is the question mark. If the height of the flame H naught is equals to how much? 2.4 centimeters. Find the height of the image. Hi, how to find? State state whether the image formed is erect or inverted image. You know, all real images are inverted images. All real images are inverted images. So first of all, we are going to find the focal length of the mirror using mirror formula. What is the mirror formula? 1 by f equals to 1 by v plus 1 by u. What is the image distance? Minus 60 centimeters. What is the object distance? Minus 30 centimeters. What is LCM of 60 and 30? 60, because they are multiples of 30. So 60 is the LCM. 60 ones are 60. So minus 1, 30 ones are 32. So 1 by f equals to minus 3 by 60. How much you get? F equals to 3 ones are 3 tens are. F equals to, make it reciprocal on both sides, minus 10 centimeters. So focal length negative means which mirror? Concave mirror. And let me find the magnification. M equals to, formula is minus V by U. What is the minus V? Minus 60 The formula also minus there. U equals to minus 30. 30 ones are 32s are. So minus minus also cancel. M equals to minus 2. So magnification minus means it is real image, real and inverted. So more than one is enlarged image. M equals to, we can also write Hi by H naught. You ask to find the what is the Hi. Hi is equals to M into H naught. M equals to minus 2, H naught equals to 2.4. No, simply Hi will get 4.8 centimeters. So you got an enlarged image on the screen, which is inverted image because magnification value is minus. Sorry, height of the image is minus means it is below the principal axis. It is inverted images. Simply how to remember all real images are inverted images. The next question, a spherical mirror produces an image of magnification minus 1 on a screen placed at a distance of 50 centimeters from the mirror. So what is the magnification? M equals to minus 1 and object distance equals to minus 50 centimeters. Object distance always taken minus. Write the type of mirror. Now tell me which type of mirror forms real images? Convex or a concave? Very good. The given mirror is concave mirror. Find the distance of image from the object. The magnification formula M equals to minus V by U. M equals to minus 1 minus V minus 50. Minus minus cancel, cross multiplication. So V equals to minus 50 centimeter. There is no need to solve the sum because magnification minus 1 means the object is placed on at the center of curvature. When the object is placed at the center of curvature, where the image forms, image also formed at the center of curvature. Means object distance is equals to image distance. So what is the image distance here? Minus 50 centimeters. What is the focal length of the mirror? What is the focal length of the mirror? Object is placed at the center of curvature. Means object distance is equals to radius of curvature, which is equals to minus 50 centimeters. You know R equals to how much? 2F. R equals to minus 50 centimeters. 2 into F. 2 ones are 225. Then F equals to how much? Minus 25 centimeters. This is the focal length of the uh, given mirror. Draw the ray diagram to show the image formation of in this case. How to draw the ray diagram? Which mirror it is? Concave mirror. Fold. Take the equal distances. Fold to focus. At the same distance, mark the center of curvature. Means the distance between pole to focus and center of curvature should be same. Place the object at the center of curvature. A light ray which is passing on the mirror parallel to the principal axis passes through focus. If the light ray incident through focus, after reflection, it passes parallel to the principal axis. So image is formed at the C only. So you should maintain a scale to draw the proper diagram. The next question, a student wants to project the image of a candle flame on a screen 48 centimeter in front of a mirror by keeping the flame at a distance of 12 centimeter from its phone. Suggest the type of mirror he should use. Find the magnification of the image produced. How far is the image from its object? Draw the ray diagram to show the formation of image in this case. In the question, the image is forming on the screen. As the image is forming on the screen, the image is real. Only concave mirror can form real images. So you must use the concave mirror. Find the magnification. The image distance equals to 48 centimeters and object distance equals to 12 centimeters. So use the sign convention rule here. Object distance always taken negative and image distance also minus because image is formed in front of the mirror. So magnification formula m equals to minus v by u, minus of minus 48 is divided by minus 12. Minus cancel, 12 ones are 12 fours are, m equals to minus 4. Magnification minus 4 means image is real, inverted and enlarged. Next question. How far is the image from its object? Let us draw a ray diagram. Concave mirror, pole, focus, center of curvature. So you will get real inverted and enlarged image only when if the object is placed between focus and center of curvature. The first rule is the light ray is incident parallel to principal axis. After reflection, it passes through focus. Next rule, if the light ray is incident through focus, after reflection, it passes parallel to principal axis. So the image is formed behind the center of curvature, which is whose size is more than the size of the image, means it is real, inverted and enlarged. The question is, we need to find out the distance between the object distance, means object and image, not object distance, image distance. We have to find out what is the distance between object and image, means you have to find this yellow color distance. This is the object O, is image I. So we need to find OI. OI equals to PI minus PO. PI, P to I, all the distance must be measured from the pole of the mirror. So P to I is the image distance. Image distance is 48 centimeters. What is the object distance? P to O is 12 centimeters, which is equals to 36 centimeters. This is the distance between image and object. The next question, list the new Cartesian sign convention for reflection of light by spherical mirrors. We have to explain the sign convention rules. Draw a diagram and apply the sign convention rules for calculating the focal length and nature of spherical mirror which forms a 1 by 3 times magnified virtual image of an object placed 18 centimeters in front of it. So we have to find, first of all, the first thing here, sign convention rules. And now this question is regarding the convex mirror. Why? Because it forms 1 by 3rd times magnified virtual image of an object placed 18 centimeters in front of it. Now first of all, what is the magnification given? M equals to plus 1 by 3, because as given the virtual image, and object distance equals to minus 18 centimeters. Calculate the focal length and nature of the spherical mirror. So nature of the spherical mirror is convex mirror. What is a mirror? Convex mirror, because convex mirror only always forms virtual, erect, and small size images, diminished images. Okay, only convex mirror forms this type of images. So let me find the focal length of the mirror. Magnification m equals to minus v by u. So m equals to minus, what is m value here? M value is plus 1 by 3 minus v by u equals to minus 18. So minus minus cancel, 3 ones are 3 6 are. So v equals to 6 centimeters. Let me find the magnification. There is no need to find the magnification because you already given the magnification 1 by third. Next is focal length. Using the mirror formula, 1 by f equals to 1 by v plus 1 by u. 1 by f equals to 1 by v equals to 6 centimeters plus 1 by u equals to minus 18 centimeters. So 1 by f equals to 1 by 6 minus 1 by 18. Now 6 comma 18 LCM is 18. 6 ones are 6 threes are 18, 18 cancel 1. So 1 by f equals to 2 by 18. 2 ones are 2 nines are making reciprocal on the both sides. F equals to plus 9 centimeters. So focal length positive, it is convex mirror definitely. And also the question is explain the sign convention rules. You know the first sign convention rule, all the distances must be measured from optic center. Let me draw a ray diagram for this question. It's a convex mirror. Pole, focus, center of curvature. You can place the object anywhere on the principal axis. Rule number 1, if the light ray is incident parallel to the principal axis, it diverts through the focus. It seems to be reflect from the focus. If the light ray is incident through center of curvature, it does not deviate. The both reflected rays seems to be intersect at the point between pole and focus. So this is the point where the virtual images forms. Now this is the object and this is the image. The first thing is rule number 1, all the distances must be measured from pole of the mirror. Second, the distances which are measured in the direction of incident ray. This is the direction of incident ray. They are taken as a positive. Means P to F. P to F is the focal length, but I am measuring from the in the direction of incident ray, so focal length is positive here. And P2O is the object distance. I am moving against the incident ray because P2O is the object distance. This is the incident ray direction. This is the object measurement direction. So I am measuring against the incident ray. So object distance is negative here. And the heights of the images and objects which above the principal axis above the principal axis are taken positive, below the principal axis they are taken the negative. The next question, an object placed 12 centimeter distance from pole of a concave mirror and image is formed at 4 centimeters from the pole, find the focal length of the mirror. Given mirror is concave mirror. What is a given mirror? Concave mirror. What is the object distance? The object distance is 12 centimeters and image distance is 4 centimeters. Question, we have to find what is the focal length of the mirror. After the sign convention rules, object distance always taken minus. As the image is formed in front of the mirror, so it is taken minus 4 centimeters. Using the mirror formula, 1 by f equals to 1 by v plus 1 by u. V equals to minus 4, u equals to minus 12. 1 by f equals to minus 1 by 4 minus 1 by 12. LCM 12. 4 ones are 4 threes are 12 ones are cancel. So 1 by f equals to minus 4 by 12. 4 ones are 4 threes are. So 1 by f equals to 1 by 3. So you will get the f equals to 3 centimeters. It is plus. Is it plus or minus? Minus. Minus. So f equals to minus 3 centimeters. So as a focal length is negative, the given mirror is concave mirror. Next question. Focal length of concave mirror is 30 centimeter. The image distance is 60 centimeter. Then the possible object distance. The focal length of the concave mirror f equals to minus 30 centimeters because it is concave mirror. Focal length is taken negative. And image distance equals to 60 centimeter. Then the possible object distance is telling. F equals 30 means what is the radius of curvature? R equals to 2f. So R equals to 2 into 30 equals to 60 centimeters. So radius of curvature equals to 60 centimeters. If you draw the diagram, pole, focus, center of curvature. Now P to C equals to 60 centimeters. The image is formed here. Now what is the object distance he asking? Definitely the object should be on the center of curvature itself. When the object is at the center of curvature itself, the object distance will be 60 centimeters. Now there are two options, plus 60 centimeters and minus 60 centimeters. You know the object distance always must be taken the minus. So option is minus 60 centimeters. The last question, a security mirror is used in a big showroom as radius of curvature 5 meters. If a customer is standing at a distance 20 meters from the cash counter, find the position, nature and size of the image formed in the security mirror. In this question, the security mirror must be at the cash counter only. Now tell me what is the mirror at the which is used as a security mirror? It is a convex mirror. So the mirror is convex mirror and radius of curvature is given r equals to 5 meters. You know r equals to 2f which is equals to 5 meters. Then f equals to 5 by 2 meters. As a given mirror is convex mirrors, according to sign convention rule, focal length is positive. F equals to 5 by 2 centimeters. And object distance u equals to minus 20 meters. Let us find the what is the image distance using the mirror formula. 1 by f equals to 1 by v plus 1 by u. 1 by f equals to 5 by 2 equals to 1 by v, that is a question mark we have to find, plus u equals to minus 20. Then 2 by 5 equals to 1 by v minus 1 by 20. Then 2 by 5 plus 1 by 20 equals to 1 by v. Now 5 comma 20 LCM is 20. 5 ones are 5 fours are 4 twos are 8 plus 1 equals to 1 by v. Then 1 by v equals to 20 by, so 9 by 20. Then what is the v value? V equals to 20 by 9 meters. So you're asking what is the position and nature size of the image formed here. It is not possible to find the size of the image because we don't know what is size of the object here, but you can write approximate value here. So let me find first of all nature of the image. For this you have to find the magnification. The magnification m equals to minus v by u m equals to minus v by u minus of 20 by 9 is divided by, what is the object distance? 20. It is minus 20. So minus 20 cancel, m equals to plus 1 by 9. So plus 1 by 9 is magnification, plus means virtual erect, and my 1 by 9 means less than 0, it is diminished. You know, convex mirror always forms images between pole and focus. So that is the size of the image is diminished image, and the position of the image is between pole and focus. What is the nature of the image? Virtual and erect.